everybody. It's 1 o'clock.
All right,
I think we can get started. We've got 24 people on at the start here. Hopefully we can get a few more. My name is Suresh Srinivasan. I coordinate the Beginner Special Interest Group for the Minnesota Astronomical Society. I'm pretty excited to welcome Claire Weaverling as our presenter today. Claire, as I've said in my notes earlier, has really come up the charts really fast as a visual observer. Claire says that she's been involved in astronomy for about maybe 10 years or so, and member of the club for about that long maybe. But the last couple of years, she's really become really active, and she's completed a lot of the Astronomical League lists. I know most recently she's been working on the binocular Messier, which I think she might have completed.
I'm done, yeah.
Yeah, and now I think she's working on the moon program, the lunar program over the winter. And so she's quite knowledgeable, and she uses an 18-inch obsession that she got from the club, 2 years ago, about that. And so that's what she uses for the most part these days. You can often find her there it is on screen. And you can often find her at CGO on those cold nights, looking for obscure, faint objects somewhere in the heavens. So with that, I'm going to introduce Claire Weaverling.
All right, welcome everyone. Happy Saturday.
I said that wrong. Weaverling.
I realized Weaverling.
Sorry.
I realized we have a week from today is Christmas, so I'm a little stressed out. I'm like, oh crap, I got a lot of work to do before next Saturday to be ready to host people. So.
Oh, before you start, real quick, Claire, just a couple notes. Please, everybody, turn off your cameras to save bandwidth. And if you have a question, please put it into the chat as opposed to asking it out loud. And when Claire stops or pauses, I will read out the question to her to keep her rhythm and flow going. So with that, go ahead, Claire.
All right, welcome everyone. Today we're going to talk about the winter constellations, and I think Suresh already gave a brief intro. I've kind of been interested in astronomy for like 20 years, but it took me many years to start getting actually serious about it. Actually, I bought my first telescope about 10 years ago, and it was a 12-inch Orion Dobsonian Newtonian reflecting telescope. And then 2 years ago in 2020, I think it was, I was up at Northern Night Star Festival with my 12-inch Dob, and I looked out on the field and I saw much larger Dobs than my own. And I made a comment to somebody, I'm like, I think my Dob is the smallest Dob on the field. And then I got what a lot of people joke is called aperture fever. I decided I needed a larger scope, and it turned out that MAS had an 18-inch obsession that they were trying to get rid of. And so I made this purchase 2 years ago. It's always good to have a scope that's taller than you are, as you can see. And then right about that time, I think it's about 2 years ago, Trina, our president, our newly elected president who's on this call, she talked me into working toward my master observer status. And so I'm currently doing that. Hopefully you're familiar with the Astronomical League programs. I really enjoy these because I feel like it gives me a way to focus. As Suresh said, my main interest is visual observing. It gives me an actual project to work on where I can focus, and I can also see a wider range of objects than I might pay attention to if I was just going out in the field trying to make something up. And I also enjoy having something to work toward. Once you finish one of these programs, you get a little pin, you get a certificate, you get your name in the monthly magazine, The Reflector, and that's pretty cool. So I highly recommend these programs. I've finished the Messier and Caldwell lists and also binocular Messier. Last summer, I worked on the globular cluster observing program. So I did 50 globulars over the course of the summer. That was my absolute favorite thing so far. I'm currently working on the open cluster project. I'm about a third of the way through that, but I'm going to put that on hold probably till summer. And then as Suresh said, I'm working on the lunar program over the winter. So definitely check those out if you have not done so. But given what I just kind of covered as my background, I wanted to focus today more on visual objects. So we're going to talk about the winter hexagon and tour around a little bit. Check out some of the major stars and constellations that are there, and with a focus on deep sky objects that you might check out. And I wanted to do a range from naked eye objects that you can just walk outside, look at them, they're beautiful, you don't need any equipment, on up to stuff where you might need a pair of binoculars at least, and then on up to something where you might need a telescope and even some more equipment. So trying to give you a variety of objects to check out. And then I'm going to utilize the Messier and Caldwell list for today, just because the Messier list is very well known, and it gives us some of the bright gems of the nighttime sky and objects that are very accessible for beginners. And then I've thrown in some Caldwell objects as well to just broaden out our list. And the Caldwell list was a British amateur astronomer named Patrick Moore, who put together his own collection of objects that were not in the Messier list. So that's what we're going to focus on. I'm actually going to turn off my camera here. I tend to want to gesture. I don't know if I can figure out how to. Okay, never mind. I'll leave my camera on. If you see me gesturing a lot, hopefully it's not distracting, because I tend to do that when I'm talking.
Claire, if you want to turn it off, just hit on the smart, or just start video on the bottom.
Yeah, I don't have, because I'm sharing right now.
Oh,
Here, okay, I found it. There we go. Okay. All right, so here is our winter hexagon. There's actually 2 asterisms in this part of the sky at this time of year. There's also the winter triangle. So today we're going to start with Orion. If we were in the room together, I would ask you to do a show of hands, how many people know Orion. But I feel like even if you're not into astronomy, most people tend to know that constellation, since it is one of the most obvious in the night sky. So we're going to start with Orion, come down here to Lepus, over here, and I should mention the star Rigel, which is part of the hexagon, down here to Lepus, over here to Canis Major with its bright star Sirius, through this weird part of the sky named Monoceros, which is actually a unicorn, and we'll talk about that, how a unicorn got into this part of the night sky. Over here to Canis Minor with its bright star Procyon, up here to Gemini with the bright stars Pollux and the twin Castor, and up here to Origa with its bright star Capella. Mars is now in this part of the sky as well. We're not going to cover planets today, but also something that you could go out and check out. And then finally, we'll end at Taurus with its bright star Aldebaran. And before I continue, can you see my pointer when I'm pointing at things?
yes.
Okay. And I already see that we have a hand up. I just noticed that. Did someone have a question?
I think he just had his hand up.
Oh, okay.
Orion.
Oh, yeah. Thank you. Okay. Nice. I wasn't sure if I'd be able to see that, but I can see it. So that's cool. Okay. And then, like I said, there's a smaller asterism here that would include Beetlejuice. So we've got 2 different sort of winter asterisms in this part of the sky. And I know Steve was talking about tools, and I just wanted to point out that to plan this presentation today, I'm using Stellarium. It's a desktop app that's popular and fun to use. So all the screenshots that I have here are images from Stellarium.
And I believe Stellarium is free, right?
That one is free, yeah. Sky Safari, that's another one that I use. There's a free version, but also the pro version, you pay money for that. Okay, and then before we really get started with Orion, I feel like I can sit and look at pictures of the Milky Way for hours. I think it's really interesting to just try to orient yourself in terms of where we are. Sorry, I just dropped my earbud. Okay. So here's our sun and our little solar system here, about maybe 1/2 to 2/3 of the way out. And if you were outside with the BSIG this past summer, you're probably out looking at the summer constellations. So if you're looking toward the center of our galaxy, you can see that Sagittarius, the Teapot, Scorpius, those are in that direction. So in the winter at this time of year, when we're looking at Orion or Taurus or Origa, we're looking the opposite direction. So out away from the center of our galaxy, sometimes people would say toward the galactic anti-center. So that gives you a little bit of perspective. And then we're going to cover the Pleiades, the Orion Nebula, the Rosette, some of those objects. And I just think it's kind of fascinating that we might think that they're far away, but in cosmic terms, they're relatively close to us. So very, very close to our place in the Milky Way. All right, so let's start with Orion. I'm not going to get too much into mythology today. I'm not any kind of expert in mythology, but it was fun to just sort of rekindle my mind, my thoughts around what some of the stories are that are associated with this part of the sky. And so I'm going to try to do a really brief Cliff Notes version of the Orion story. And everything I say today, I got from Dave Faulkner's book. So Dave is the newly elected secretary of our club, and he's been president several times in the past. And he wrote a really great book called The Mythology of the Night Sky. If you're able to get a copy of that, please check it out. And also he did present at the BSIG, I think back in 2021. So there is a YouTube video of that. So I'm not going to get too much in depth about the mythology, but here's a really quick Cliff Notes version of the story. Okay, so Orion was the son of the god Neptune and also a Gorgon. So he was a giant of a man with the ability to wade in the ocean. He was a great hunter who would spend his time roaming about the world with his sword and his shield. He fell in love with a woman named Merope, who was the daughter of the king, King Onipion, and he wanted her hand in marriage. But the king did not want this, and therefore he gave Orion an impossible challenge, which was for Orion to rid the island of all of the wild beasts. Now, much to the king's chagrin, Orion, being the successful hunter that he was, did actually manage to rid the island of all of its wild beasts, but still the king refused his daughter's hand in marriage. So in anger, Orion got drunk and forced himself on Merope, and for this, the king had Orion blinded in both of his eyes and dumped on the beach. A little bit later in our story, Orion hears about a prophecy that can restore his vision. So he petitions the god Vulcan for help. So he needs to undergo this ordeal where he's supposed to stand on the beach and face east, wait for the sunrise. And when the sun comes up, the sun should come up and restore his sight. And while this is happening, Aurora, the goddess of the dawn, falls in love with Orion. So Orion hangs out with Aurora for a while, but still he can't forget his desire for revenge on the king. So he goes chasing after the king. Somehow they end up in Crete. And while in Crete, Orion meets the goddess Diana. Now, Diana was beautiful, and she was also the goddess of the hunt. And they were both hunters who were worthy of each other. So he forgot all about all of the other stuff with the king, and he fell in love with Diana. Now, Diana's brother was Apollo, the chariot driver for the sun. And Apollo saw that his sister was getting preoccupied with this guy, Orion, and was annoyed by that. So he went to the earth goddess and convinced her to send a scorpion after Orion to challenge him. So Orion and the scorpion become engaged in battle, and this battle rages on until eventually Orion flees out to sea. So Apollo then goes to his sister Diana, her being the great hunter that she is with her bow and arrow, and he tricks her into shooting that far distant object that she can see out to sea to just test her archery skills. So she does. She draws back her bow and shoots her arrow at this tiny object. And then when the body washes ashore, she realizes it was Orion, and she's now killed him. So she's in grief. At some point, she realizes that she can't bring him back to life, but she does plea with the god Jupiter to have Orion placed in the sky to rest among the stars, which Jupiter does. But he also places the scorpion in the sky to chase after Orion. However, he places the scorpion on the opposite side of the sky. So I'm going to go back here so you can see we've got the scorpion on the one side of the sky and Orion on the other side of the sky, where they can chase each other for all eternity, but the scorpion will never catch Orion. All right, so that's how we got the Great Hunter in our nighttime sky. Let's check out a few of these stars that we have represented here. The two brightest stars being Betelgeuse and Rigel. And then we've also got the star Bellatrix and Saiph, and the three stars of the belt, Anotak, Anolam, and Mintanka, I believe. And then we've got the sword here, and we've got a star up here called, I think it's pronounced Mysa, which kind of represents the head of Orion. So it's kind of interesting with Betelgeuse and Rigel in that Rigel is the beta star and Betelgeuse is the alpha star, but Rigel is actually brighter than Betelgeuse right now. Both of these are variable stars, and so they have changed in variability over time. So now we've got Rigel as the brightest one, even though it's the beta, but at some point in history, Betelgeuse was actually the brighter of the two stars. Now, Rigel means the leg of the giant, which you can see here. It's sort of at the foot of Orion. And Betelgeuse actually means hand of El Jazwa. So I'm imagining that in some depictions of Orion, he's got a club, but if you imagined him with his bow drawn back, this would probably be about where his hand was. Now, the first thing you'll notice about these two stars is their difference in color. Rigel is a blue supergiant, and Betelgeuse is a red supergiant. Rigel is slightly younger at 7 to 8 million years old, and Betelgeuse is older at 9 to 10 million years old. Rigel, now I mentioned when we looked at that picture of the Milky Way how close some of the stars that we can see how close they actually are in cosmic terms. So Rigel is only 860 light years away. And Betelgeuse is even closer to us at 640 light years. Now that may seem far, but some of the objects that we're going to look at later today, like globular clusters, are, tens of thousands of light years away. So again, in cosmic terms, these are objects that are fairly close to us. Okay, here's an interesting thing about Rigel. As with a lot of stars that we'll look at today, it appears to us as a singular star, but it's actually a member of a star system. There are 4 stars that make up this star system, with the brightest star being represented here, and then you can see the 3 smaller stars. It appears to us as a singular blue-white star. And the largest star here has exhausted its core of hydrogen, it's expanded, and it's cooled to become the supergiant that it is. It's also the kind of star that at some point in the future will end its life as a type 2 supernova, leaving behind probably a neutron star or a black hole. And I should mention these are artists' depictions.
Hey, Claire.
Yeah.
Just before you continue, Michael put in a couple of comments. So Dave Faulkner's book is the best reference complete for the Greek myths. And he also mentions that nearly every other ancient culture also had stories about Orion and this group of stars.
Yeah.
And he also mentions a book, A Walk Through the Heavens by Will Tyrion as a good source.
Nice. I'm going to put in a plug for Dave's book at the end, but I do know that the newest edition of Dave's book, which I don't actually have, he has included things beyond the Greek and Roman, probably the Norse, and I'm not sure what other mythologies. So again, I'll actually, there's a slide at the end where I can show you an image of Dave's book. And definitely check it out. And I'm sure there's a gazillion other sources out there for other mythologies. And again, I'm not gonna touch on all of that just for limits of time today. So I kind of just focused on the Greek. All right, and then back to Betelgeuse here. Betelgeuse is an immense star because it stopped fusing hydrogen at its core and switched to fusing helium. And with the intensity of the various reactions going on in and around the core, when a star is at this stage of life, the outer layers start to expand outward, forcing it to gain in size. So if we were to put Betelgeuse at the center of our solar system, it would be much larger than our sun and would expand out beyond even the asteroid belt. And also this is a star that's almost ready to die. And when I say almost ready to die, I'm speaking in cosmic terms, so maybe another 100,000 years before it also ends its life as a supernova. And then the other thing I wanted to mention about Betelgeuse was back in 2019. I don't know if any of you remember in the news that Betelgeuse was noticed. It was noticed that Betelgeuse was getting dimmer. This was called the Great Dimming. It's now kind of returned to normal in terms of magnitude, but I remember people saying, oh my gosh, is it going to explode as a supernova already, or what's going on? I don't think scientists exactly know what happened, but they're trying to figure it out. And it seems like the most common hypothesis is that there was some kind of surface mass ejection where the star ejected a bunch of condensed dust into the interstellar orbiting area, and this might have caused it to get dimmer. This was also the first star other than our own sun that was imaged by the Hubble back in 1995, so a direct image of another star outside of our own. All right, so now let's get into some of the deep sky objects, because that's where I enjoy. Oops, okay. I think I just gave it away. But if you were to go to the stars of the belt and down to the sword, you'll see this glowing patch of sky that looks like a star, or a hazy patch. And I'm sure that many of you have possibly already observed this object, but if you haven't, you can probably guess. It's the Orion Nebula at Messier 42. It's one of the most well-known deep sky objects. It's amazing to observe. It's also one of the most actively studied nebula by scientists. And so this is the brightest, closest region of massive star formation to Earth. Sometimes people will refer to a nebula such as this as a stellar nursery, meaning it's like a hotbed of newly forming young stars. So this is about 1,300 light years away from us, and it shines at magnitude 4 in our night sky. For purposes of amateur astronomy and looking at it visually, especially through binoculars or a telescope, you could kind of think of it in 3 parts. This main nebula right here is the main nebula, I can't remember if I said this, about 24 light years across. And then if you look at the center here, this really bright part, this is a star cluster known as the trapezium. And again, depending on how you're viewing this, if you're looking at it, the last time I looked at this through binoculars in kind of crappy conditions, I could only make out 2 stars. If you have more aperture, like a smaller telescope, you might be able to make out 4 of the stars, although sometimes the 4th star, people can have some trouble with that. If you have even more aperture, a larger telescope, you might be able to make out 4 or 6 or even more of the center trapezium. And then going back to our main image, we've got the main nebula, the trapezium, and then you've got these interesting dust lanes up here. And behind that is another patch of sky, which has earned its own Messier designation, Messier 43, and that's Demeron's Nebula. So I challenge all of you to get out there this winter at some point, check out the Orion Nebula and see how much of this detail you can make out. But that's not all in the area of Orion. So here was our Orion Nebula. If we come up here to the stars of the belt, and here's Betelgeuse that we talked about, and we go not even halfway over and slightly down, there's another interesting object known as Messier 78. Some people might refer to this as the Casper, the Friendly Ghost Nebula, probably because of its bright blue color. This is not as easy to find and see as the Orion, but also a good test of your skills. So this is an 8th magnitude diffuse reflection nebula. And by reflection nebula, I mean that the gas in the dust doesn't emit any light, but it rather is reflecting the light of the stars within the cloud. So there are 2 type B stars that are lighting up this particular nebula. And the scattered starlight glows most effectively at the blue part of the spectrum, so giving it its blue color. There's other stars in this nebula that shine more in the infrared, so not as good for visual observing. But I think when I looked at this one, I can't remember if it was through my 12-inch or my 18-inch, but definitely I was able to make out the two bright stars and to start to see some of the shape of the nebula. And now I said Orion was about 24, 25 light years across. This is about 5 light years across, so definitely smaller, but about the same distance at 1,350 light years away. Right now, I want to zoom out to show you where we were. So we looked at Beetlejuice, Rigel, here's Bellatrix and Safe, and the head of Orion, the stars of the belt and the sword. There's the Orion Nebula, and there's M78. But this whole area of the sky, as you can see, is quite amazing, and includes dark nebula, emission nebula, reflection nebula, H3 regions, which means regions of ionized hydrogen. And it's home to some very young stars, and also what they call protoplanetary disks, meaning disks of star formation. So just to point out some of the broad features here, we've got Orion A and B clouds. I think this is A, I think this is B, I could be wrong about that. Barnard's Loop, which is, you'll probably find on some observing lists. And also the head of Orion appears the Lambda Orionis ring, which I think is sometimes referred to as the Angelfish Nebula. And then we didn't talk about this one. I'm not going to put it on the list, but little tiny thing in here is the Horsehead Nebula. This is a dark nebula where the dark part of it actually looks like the head of a horse. And I'm sure many of you have probably seen that represented in images on the internet. So there's lots more that we could say about this Orion cloud complex, but I think I've given you enough to just tantalize you and get you out there observing that part of the night sky. Okay, so that cloud complex was this whole area of sky. And now we're going to come down here to Lepus, which is slightly outside the hexagon, but I did want to talk about one object in Lepus because it is interesting. And just to mention that this part of the sky represents the hare or the rabbit that Orion is probably hunting with his 2 hunting dogs. All right, so in Lepus, we have Messier 79. And this is interesting because it's a globular cluster. And we don't normally find globular clusters in this part of the sky. And so when I say a globular cluster, what I mean is a gravitationally bound group of really tight, densely packed stars, sometimes up to 1 million stars, and typically some of the oldest stars in the galaxy. Now, usually we find globulars in the halo of the galaxy, so more toward the center and around the center. But this one is on the opposite side of the sky. And scientists are not entirely sure why, but it's possible that the stars of this globular are actually native to a different galaxy, the Canis Major Dwarf galaxy. And if that collided with our galaxy, we might have gained this globular in that way. Now, that's still a matter of dispute and kind of a hypothesis, but it is fun to check out a globular that's not in the usual part of the sky. And this is a 7.7 magnitude, or about 8th magnitude, and the distance is 41,000 light years away. All right, so from Lepus, we're going to come over here to Canis Major, and with its star Sirius, which is the brightest star we have in our night sky. And this is in the constellation Canis Major, which means the greater dog. So one of Orion's 2 hunting dogs, and I guess the greater of the 2 dogs, as opposed to the other one, which is the lesser dog. And the bright star Sirius is a negative magnitude star, so minus 1.46. And I just should mention that when we're talking about apparent magnitude, that's how bright things appear to us at our vantage point, and can include, it's not the inherent nebulosity or the inherent brightness of the object, but rather how it appears to us, and that can be impacted by different things like how bright it actually is, how far away it is, how much gas is between us and that object, interstellar material, that kind of thing. So if we see a negative magnitude like this, that is really bright. So the lower the number, the brighter; the higher the number, the dimmer. So minus 1.46 magnitude. And so the Greek word for Sirius was glowing or scorching. And it was also sometimes referred to as the dog star, probably because it's in the dog constellation, but also because the ancients, noticing this star in the night, high in the night sky in the early spring or late winter, was probably meant the coming of the hot weather. So what we might call the dog days of summer, the summer heat. It could also represent the heat and dryness that scorches the crops being on its way. So obviously the ancients associated the coming of this the highness of this really bright star with the coming of the hot weather. And as with lots of stars that we'll talk about today, Sirius is also a binary. So there's a Sirius A star with a nearby faint white dwarf companion known as Sirius B. All right, let's check out some deep sky objects.
Hey, Claire.
Yeah.
Steve Emmert has a comment, and I think it's a pretty important one.
Yeah.
So go back to the M79 slide. I think those 2 slides.
Oh, sure. Let's see if I can get my animations. There we go.
There you go. So objects like this are pretty low in the sky here.
Yeah, good point.
And Steve mentions that Steve goes to Florida often. If you ever travel further south, it's good to take along, a telescope or binoculars, because these objects down here are higher in the sky down there. So if in Florida, for example, he mentions that this is 15 to 20 degrees higher in the sky.
Yeah.
And therefore you get a better view.
Yes, that's for sure. I know when I've been out doing visual observing, and Trina knows this as well from listening to me try to observe some of these objects. When they're super low on the horizon like this, they can be quite frustrating, just because there's a lot of sky glow down here. So definitely correct. If you can observe something a little bit higher up in the sky, it's definitely preferable.
But having an observing buddy is really helpful to keep you going through those really bad nights.
We call it the muckety muck, right?
Yes.
And don't forget the cocoa or the tea, something hot when it's cold.
Yeah. Okay, whoops. Sorry, I'm jumping ahead. Okay, so we just talked about Sirius. And if you go about 4 degrees straight south, again, we're going down into the muckety muck, so sorry about that, but about 4 degrees straight south, we have another Messier object called the Little Beehive. I guess it's thought to look like a little swarm of bees. And in line with what we were just talking about seeing this naked eye, this was mentioned by Aristotle in about 325 BC as one of the mysterious cloudy spots known by the ancients. So obviously the ancients could see it naked eye. Now for us, with all of our light pollution and so forth, it's maybe not as doable. But another interesting thing about this one, it was one of the first objects studied by Galileo in his telescope in 1609. And he was able to resolve it into 40 stars. So I figure if Galileo can do it with his small scope, we can do it with our larger equipment. This is a 4.5 magnitude object, and it's about 2,300 light years away. It's comprised of red giants, and you can see, and some white dwarfs. And a white dwarf meaning a sun-like star that's quote unquote dead, who's the star who's kind of shed its and expelled its outer layers into space. But you can see the white stars and some of the yellow stars. Okay, and so we were just down here, back up to Sirius and slightly over this direction, going through kind of the head of the dog. There's another lovely open cluster known as Caldwell 58. And this is nicknamed Carolyns Cluster. I mentioned that open clusters are typically newer stars, but this one is one of the oldest known open clusters at 2.2 billion years old. But what's cool about this one is that it was discovered by an astronomer, Caroline Herschel, who was the younger sister of the famed astronomer William Herschel. But she was the first woman to win the prestigious gold medal of the Royal Astronomical Society, and she earned this award for her work verifying her brother's observations and compiling a catalog of nebula. But in addition to that, she also discovered several of her own objects, and this was the first object that she discovered. She described this as a beautiful cluster of pretty compressed stars near a ½ degree in diameter. Actually, I don't know if I did describe an open cluster. I mentioned globulars. And so an open cluster is also a gravitationally bound cluster of stars, but stars that are a little more loose and also will at some point in the future probably disperse. They're probably on their way to migrating somewhere else and will eventually lose their gravitational connection and wander off. But at least for right now, they make up some of the prettiest objects in the night sky, and typically tend to be younger stars than the globular clusters. This one is a 7.2 magnitude. It's 3,700 light years away. This should be doable with both binoculars or a telescope, and depending on your aperture, you know, maybe in a binoculars, you can resolve about 30 widely scattered stars, and in larger magnitude, like my 18-inch scope, you should be able to resolve quite a few individual stars. Okay, this next one is an awesome one. I really like this. This is Caldwell 64, Tau Canis Majoris, another open cluster. And so Sirius was here, we came down here, we were over here, and now we're coming down closer to the tail of the dog and slightly over. This bright blue star is the Tau Canis Majoris star, and that's what gives this cluster its name. And it's also a member of the cluster, so it doesn't just appear to us visually. It is actually gravitationally a part of the cluster. And what's interesting about this one is that this is similar to the Pleiades in that it's about the same size as the Pleiades, and it also contains mostly young and hot blue-white stars and some associated nebulosity, so the remains of the gas cloud from which these stars formed. But because this cluster is some 10 times farther away, it's much fainter and smaller in the sky from our vantage point. And then going back to Dave's book, this one you'll see sometimes nicknamed the Mexican jumping star. And I guess the reason for that is that if you're looking at it and somehow your telescope jiggles, like from wind, or you accidentally move your scope, it can look like this bright star goes in one direction and the background stars go in the other direction. And the reason for that is probably retinal persistence. The brightness of the star stays on your retina, even though what's in your eyepiece moves. So therefore the name, the Mexican jumping star. This one's a little bit misleading with magnitude because the main star is a 4.1 magnitude, but the cluster itself is actually 7th magnitude, which can make it a little tricky visually. But in my 10-inch scope, I was definitely able to see the main bright star. And I kind of described it as looking like it looked a little, had kind of a rose-like shape, some rose petals around it. All right, here's the unicorn.
So Claire, just before you start Montessori,
Yeah.
Does anybody have any questions so far of what Claire has discussed, or any comments? This would be a good time to ask. I don't see anything in the chat.
Okay.
Oh,
I'm
go
probably
ahead.
moving through these quickly just to give you the sort of range of things, and we can always come back to any of these objects in particular if you're interested.
I don't see any comments. Go ahead.
Okay. All right, so this is a weird one. So we've got obviously the Orion story with a hare and his 2 dogs. And then smack dab in the middle is a unicorn. I'm not going to get too much into the story behind that, but probably the ancients did not see this part of the sky as having many stars or really representing anything visually. So there's not an ancient constellation associated with it, and there's no mythology But the unicorn is one of the more modern constellations that came to us from a guy named Plancius. Of the constellations that he tried to introduce, about 2 of them kind of stuck. And so now we have a giraffe here in the middle of our Orion story. But even though this part of the sky is not too impressive in terms of constellations, there are quite a few deep sky objects represented. And the first one is another Messier object, another open cluster. And this is a large, bright open cluster nicknamed the heart-shaped cluster. And it's a 5.9 magnitude object, distance about 3,262 light years. In my description of this one, I described it as a lumpy circle rather than a heart, but maybe if you observe it, you can make out more of the heart shape. And then another of what I probably would say was one of my favorite Caldwells. It's very tiny, but if you can make out the detail of it, it's pretty cool. This is Caldwell 46, Hubble's Variable Nebula. It's another reflection nebula that kind of looks like a small comet. So this massive star here that's dubbed R Monocerotis, this star is giving the nebula its brightness. And there's some interesting dynamics going on with this, where the dust in this nebula can sort of change in configuration over time. So within the course of just a few weeks, it can change its appearance, and therefore the name Variable Nebula. And it was Edwin Hubble, the astronomer, who carried out some of the earliest studies of this object, and so it also carries his name. And you'll notice that the star can't be seen directly, but we're actually seeing the star behind the nebula. And my description of this one in my 18-inch with a 9mm eyepiece, I said that I really could make out this little triangle flaming off of the bright star. It was quite cool. And this is a 9th magnitude object. The distance is 2,609 light years away. Oh, and I forgot to point out where this is. So we've been down here, and now we're coming back up here to where Beetlejuice is, and we haven't yet talked about Procyon, but kind of this line right here between the two, a little less than halfway here and slightly up is where you will find that object.
Claire, would you say that that object is one of the strangest ones to look at through a telescope? That's what I remember. It's just weird looking.
Yeah,
right?
I remember, it's been a while, but I remember it being like tiny. It's tinier than you would think, but if you can get the detail, yeah, I would say it's one of the weirdest and therefore one of the coolest. So does that sound right from what you remember?
Yeah, definitely. You see the shape, you see that triangle shape.
Yeah.
And it is definitely smaller than you'd expect, but you actually see some pretty good detail.
Yeah. Yep.
I should also mention Michael Cowper put a comment in the chat. He works with young kids all the time, and he always mentions a story about Canis Major, the big dog, and how it got in the sky.
Oh, funny.
And he mentions a book, Wishing Upon a Star by Fran Lee. And he also mentions the story is actually from India, which he finds unusual.
Oh, nice. I was thinking, I don't mean to digress, but I had intended to put all these objects on a list to share with everybody. So if you could put those resources, Suresh, in the chat, I could add some of these resources to the list, and then we could email that out to people after the fact.
That's a good idea. All right, yeah. I'll do that.
Okay, yep. All right, and then I'm going to move to one. We went back on that Milky Way slide. There was a little X where the Rosette Nebula was located, and this is the Rosette. This is Caldwell 4950. This is a twofer where you get 2 Caldwell objects in one. So the central star cluster is its own object, and then the surrounding nebula is an object. Now, again, we're in the same line between Procyon and Beetlejuice, about halfway, and then not quite halfway, and then down a little bit. I would describe this one as actually a challenge object. I thought it was tricky, and I know it's notoriously tricky for people, although I've seen other people mention that it's super easy for them. So I don't know, I found it difficult, but maybe some people have better luck with it. I thought it was very easy to get the central cluster and sketch it. Some of the surrounding nebulosity, I would recommend that you have really good sky conditions, and you probably need a little bit bigger scope. Definitely use a filter on it, like an O3 filter or a UHC filter to try to get some of the nebulosity. But this one is cool because it is actually, you wouldn't think it, but it is actually much larger than the Orion Nebula that we looked at. I talked about that one being about 24 light years across. This one spans about 130 light years. Because it's so much farther away, it's not as striking in our skies as the Orion is. So this one is about 5,219 light years away. But like the Orion Nebula, it's a stellar nursery of hot young stars, and that also light up the surrounding area. So the radiation ionizes the surrounding clouds and causes it to emit its own light. And this one glows in more of the red part of the spectrum, therefore giving it, obviously, its nickname, the Rosette Nebula, and also the shape of it that kind of looks like a rose. Although sometimes people refer to this one as the Skull Nebula also. I don't really see as much of the skull, but maybe somebody does. And then those of you who, I know some people from the club go down to Oklahoma. If you're not aware, the Rosette Nebula was officially named the astronomical object of the state of Oklahoma. I just happened to come across that. I didn't know that was the case.
I forgot the lady's name that spearheaded that.
Right.
Yeah, I can't remember her name now. Oh, Trina mentions that with the Rosette, she had a hard time seeing the nebulosity.
You did as well? Yeah. Yep, I would second that. All right, our next Caldwell, one other open cluster here in Monoceros. And so we were on this line between kind of Beetlejuice and Procyon. Now we're coming straight down from Procyon again and back in the neighborhood of Sirius, kind of making a triangle here. And this is another open cluster, mildly elongated, 7.6 magnitude, about 11,286 light years away. I could find nothing interesting about this nebula really on the internet, but in my own observing notes, I enjoyed it. I said that it had kind of a, when you first pass over it, it has kind of a face-on spiral galaxy, or maybe again like a rosette flower shaped shape to it that I thought was pretty, and a little bit of distinct white nebulosity with this scattering of the pretty stars. So I threw this one in here because I did think it was quite pretty. Okay, now we're going to pass over the unicorn, and we're back to the Orion story. Here's the greater dog, and now we're in Canis Minor with the lesser dog and its bright star Procyon. I don't have any, we don't have any Messier or Caldwell objects in this part of the sky, but I will talk briefly about this bright star. So again, this is one of Orion's 2 hunting dogs, and the name comes from the ancient Greek meaning before the dog, because it precedes Sirius, the dog star. When it rises in the sky, you can see it's further north than Sirius and comes above the horizon before Sirius does, therefore the before the dog star. It's the 8th brightest star in the night sky. It's 0.34 magnitude, and it is one of our closest neighboring stars. It's 11.46 light years away. And again, it's not a singular star. Procyon B is a white dwarf star that's actually larger but less massive than Procyon A, which is the brightest of the 2 stars, and also a star that's on the way to becoming a giant star. All right, so let's move up to Gemini here, from Procyon up to Gemini and the twins, Pollux and Castor. I'm gonna try to give you a Cliff Notes version of the story from Dave's book. What's kind of interesting is that we've had the Orion story down here, and this mythology up here is a completely different story. Not part of the Orion story, but rather the Jason and the Argonaut story that includes the Golden Fleece. And I'm not going to tell that because that would be very long and take too much time. But Castor and Pollux figure into the Jason and the Argonaut story. And then later after that mythology comes to an end, there's a story involving the two of them that's more to the point. So Castor and Pollux were twins and half-brothers. Both were the sons of Leda, a mortal woman. But Jupiter was the father of Pollux, and Castor's father was a mortal. Now, when Jason put out the all-call for brave, strong young men to join his crew to set sail to retrieve the Golden Fleece in the Argo ship, the twins Castor and Pollux were among those who volunteered, and they became known as Argonauts. Now, many adventures ensued, but after all of that was said and done, Castor and Pollux participated in a cattle raid randomly and were killed. Since Pollux was Jupiter's son, the son of a god, Jupiter offered him immortality. But Pollux refused unless he could share it with his brother, who was mortal. So Jupiter compromised, and if Pollux was willing to endure half his time down in Hades with Castor, both of them could be placed in the sky the other half of the time. So half of the year they're down in Hades below the horizon, and half of the year they're shining in our night sky. Now, these two stars are not gravitationally bound to each other, so they're separate, but it's another situation kind of with Rigel and Beetlejuice, where Pollux is the beta star, but it's slightly brighter than Castor, and Castor is the alpha star, but it's slightly dimmer than Pollux right now, but probably at some point in history that was reversed, therefore giving them the alpha and beta designations. I think I have I have an artist depiction here. So Pollux is a magnitude 1.14 star, and you'll notice that it glows more golden. It's about 34 light years away. It's a yellow-orange giant star that, again, has evolved to shed its hydrogen and expand into its giant phase. And it does also have a confirmed exoplanet that's about twice the size of our own Jupiter. And Castor here glows whiter, so more white, with a combined magnitude of 1.58, because again, it's part of a complex system. Now, instead of being a binary, this one is actually a sextuple star system, so meaning 3 pairs of binaries that scientists break down into 3 visual components. But the combined magnitude is 1.58. This is 51 light years away. I think in terms of resolving these, it can be seen as 2 stars and then possibly a third dimmer star beyond that. But other than that, it can't really be resolved visually except by scientists using a spectroscope. Okay, now deep sky objects in Gemini. Shockingly, I know, another open cluster, Messier 35. This is a rich open cluster consisting of several hundred stars, of which 120 are brighter than magnitude 13, with a fairly dense center. And this is a 5.3 magnitude object. This is about 2,800 light years away. And then another really cool object. This is Caldwell 39. Oh, I forgot to show you about where we are. So here's Castor and Pollux, and we're just slightly down and over. And here's Procyon down here. So you could also sort of jump up from Procyon. This is a planetary nebula. It used to be called the Eskimo or clown face, but because those could be considered offensive, NASA no longer uses those names. I've also seen it referred to as the Lion Nebula, and I really like that because I think it does actually look like a lion. This object has been forming for about the past 10,000 years, and the central bubble that you can see here is formed by the high-speed wind from this dying central star, and then you have this dark ring, and then the outer shell is somewhat mysterious to scientists. They're not actually sure what what has caused this pattern, but they think it might be caused from the collision of slow and fast moving gases. That some scientists describe this as having kind of comet-like things that come out like that. Also, this one is composed of two elliptically shaped lobes of matter streaming above and beyond the dying star. And in this photo, the one bubble lies in front of the other, so therefore obscuring part of the second lobe behind it. This is a 10th magnitude object about 4,200 light years away. I did use a UHC filter on this one in my larger scope, and I could make out the bright central star and the dark ring, and just barely felt like I could make out a little bit of texture in the outer halo. I would definitely, I don't know if anyone disagrees, I would definitely consider this one probably one of the challenge objects.
So when I've seen this one, I can actually make out a little bit of detail in the central area.
Yeah, some of the.
Yeah, it's actually quite an astonishing object to look at in
Yeah.
the telescope. It kind of just jumps out at you.
Yep. When I put this presentation together, I decided some of these I need to go back and check them out again. And this was on the list.
So Michael Copper also mentions going back to CastroPollux. That in that book he mentioned, in A Walk Through the Heavens, there's a story about CastroPollux as told by the Maori of New Zealand.
Oh, cool.
And I find that interesting because think about from New Zealand how low in the sky CastroPollux would be. So, because they're in the far south, obviously.
Yeah.
So
that's really cool.
Yeah.
Okay, I'm not going to talk about meteor showers, but just mentioning that the Geminids is this month. I know we already passed the peak, which was, I think, on the 13th and 14th, but we can probably still see some meteors out there right now. I think it's supposed to be one of the brighter of the meteor showers during the year. Has anyone been out to see any of it?
I thought I saw
crappy weather.
I thought I saw some the night of the Mars occultation. I thought I saw some Geminids potentially.
Okay, let's see, we're up here at Origa, and then we'll end at Taurus. So we're almost done with our tour. I'm sure there's other world mythology. I'll just give you briefly, again, going back to Dave's book, I'll give you the brief story of why we have, it's not a chariot, but rather a charioteer in the night sky. Again, we have a king whose name I can't pronounce. So King and Onimus, let's say King Onimus, had a beautiful daughter who was much sought after for marriage, but there was a prophecy foretelling the king's death at the hand of whoever married his daughter. So he conspired a chariot race for any suitors who might seek his daughter's hand in marriage. The winner of the chariot race could marry her, but if they lost the chariot race, they would be slain by the king. Now, the reason this was kind of sly on the king's part was that he had the best horses, the fastest chariot, and the best charioteer. The charioteer was a guy named Myrtilus, who was the son of Mercury. So a bunch of men lost their lives in this challenge, but finally there was one suitor who decided to conspire with Myrtilus to rig the king's chariot, and therefore promising Myrtilus half the kingdom if he won the chariot race. And the reason why Myrtilus was tempted to do this was he was also secretly in love with the daughter and thought that if he could get half of the kingdom, that might win over her love. So Myrtilus rigged the king's chariot, and during the chariot race, the king hit a pothole, the wheel came off, and the king became tangled in the reins and was dragged off to his death. But then the suitor reneged on his promise to Myrtilus and did not give him half the kingdom. So the two of them fought, and Myrtilus was tossed over a cliff and into the ocean to his death. So Mercury was sad at the death of his son and placed the charioteer into the sky. But he's usually represented as having no chariot, his reins are broken, and he's saddened by the treachery. And our bright star Capella, the bright star of this constellation, is sometimes referred to as the goat star. It could be in the ancient Greek a she-goat or a little goat, and it's typically seen as representing Amalthea, which was the goat that suckled the the god Jupiter or Zeus in Greek mythology, but also the charioteer is often represented holding a goat with her two kids. So therefore the goat star. And I bet there's other world mythologies associated with this. I think even in Greek mythology, there might be slightly different stories to represent that one.
So Claire, just on a quick side on that.
Yeah.
You know what the closest moon of Jupiter that has fairly large size. It's not one of the Galileans, but you know what the name is?
Io, Callisto, Ganymede, and Europa. Which
closer.
Oh, which?
Amalthea.
Oh, right. Yeah. I think I did know that.
They tie these things together.
Okay, so the goat star. Yeah, I had a note here. 160,000 years ago, Capella was the brightest star in the night sky. I had not known that actually. But this shines at a magnitude 0.08. It's about 42.9 light years away. And yet again, it looks like a single star, but it's actually a quadruple system with two binary pairs. And also, apparently, this is one of the brightest sources of X-rays in our night sky, which are thought to be from the corona of the brightest star of this system. All right, there are, I think the theme of our day today is open clusters, and there are three. I think what's fun about Origa here is that there are several objects that are in very close proximity to each other here. And you could probably do this in one, I don't know, in one little tour here on one night. So starting with M36 open cluster, which is right here. This is also known as the pinwheel cluster. And of the three objects I'm going to talk about right now, this is the faintest of the three. It is in the Messier catalog, it's one of the most distant objects that Messier cataloged. So it's the smallest, least populated of the three clusters. It's magnitude 6.3, and the distance is about 4,100 to 4,300 light years away. Messier 37 is considered to be, I just said the other one was the dimmer. This is considered to be the brighter and richer of the three. This is a 6.2 magnitude object, about 4,500 light years away. And this one contains more than 500 members, of which 150 are stars brighter than magnitude 12.5. So quite rich. And it contains at least 12 evolved red giants and also hosts a large population of white dwarfs. And I think I mentioned the white dwarfs are those sun-like stars that are, you know, quote unquote dead. And then lastly, so right nearby here, we've got Messier 38. And this one is referred to as the starfish cluster. This is a 7.4 magnitude object, distance 3,480. And some people think that this one, in addition to being the starfish, makes kind of an X or a cross shape, or sometimes people say it looks like the Greek letter pi. So this would be a fun project for a night, just hop around to these three different open clusters. And if you want to add a bonus object to that, we've also got a Caldwell object, the flaming star, also in proximity to those three right down here. This is another really cool object. It's magnitude 6, about 1,500 light years away. This is an emission and reflection nebula. And this bright star, which is known as AE Origa, is actually not formed from the nebula, but is a runaway star that just happens to be passing through this area of the sky at high speed and producing a violent bow shock. And also lighting up this part of the sky. It's also cool because this star, when scientists have studied the proper motion of the central star, they can trace it back to the Orion area, possibly the Orion's belt area, or possibly even the trapezium. So about 2 million years ago, it's possible that there was a collision of two binary star groups that sent this star kind of on its trajectory all the way over here. And now it's lighting up this part of the sky.
Hey, Claire,
Yeah,
for the previous 3 open clusters, M36, 37, and 38,
yeah.
which do you think is your favorite of the 3? Or
Let me look at my notes. I'm not, again, I have more notes than what I'm actually giving you. So let me scroll up here to my notes. I think I've done I've done these in both binoculars and a telescope, although.
can you show people those slides again?
Yeah, let me go back here. I think I'm guessing probably M37. Let's see. M36, I had it described as a loose cluster. Let me go back. A loose cluster. I actually thought this one was neat, even though my note says it looks like it has kind of curved arms that are spiraling out a little bit. M37, I said it is bright and it's dense. And I described it as, I don't know, I guess everything, it kind of has a flower shape at some point, but it kind of flowers out with rose petals, and that the center was really bright. So I would say this one was more spectacular in my notes.
Yeah, I would agree. I would think 37 is of the 3 is the best.
Yeah.
And also, I recall 37 is visible to the naked eye under dark skies.
Probably, yeah. And then, yeah, maybe this was, what is my note on this one? Bright white diffuse with a dark center. And this one I did have a note that the bright star was definitely apparent. And to me, the nebulosity, I had described it as making kind of a Y shape. I guess I meant like this was maybe the top of the Y somehow. I did use a UHC filter for this one as well. All right, and then finally we've arrived at Taurus the bull. How are we doing on time, Suresh? Are we good?
Plenty of time. You're doing great.
All right. So I'm going to do this Greek story from David's book really quick. There's multiple stories about the bull, so I chose the one that was the briefer and simpler story, I think. So in one of the stories, Jupiter was in love with a beautiful young woman named Europa and would watch her from the heavens, gathering flowers by the seashore with her friends. He dared not do anything for fear of the jealousy of his wife Juno, until the goddess Venus and her son Cupid conspired to shoot an arrow through Jupiter's heart, in which case he could not resist. He turned himself into a white bull that appeared to the young maidens, and Europa's friends convinced her to jump on the bull at some point, and when she did, Jupiter rode off out into the sea. At some point, she realized that he wasn't a bull, he was actually the god Jupiter, and they went off to a secret hideaway in Crete where they became lovers, and she bore him 3 sons. And so then here we have the bright star Aldebaran. I know people pronounce things differently, and I know pronunciation is people get in, we have like sort of joking arguments about how to pronounce things. But I'm going to say Aldebaran. And this kind of looks like it should be part of the Hyades here. We'll talk about the Hyades in a second, but it's actually not. It's a star that's kind of between us and the Hyades, off on its own, doing its own thing. This is the brightest star and the Alpha star. It's a reddish, giant, cooler star, cooler than our sun, but much larger and more luminous. And from the Arabic, it means the follower, since it follows the Pleiades here in the night sky. It also it varies in magnitude from 0.75 to 0.95, and it's 65 light years away. And again, it's not really associated with any other nearby stars or objects. It's kind of off by itself. All right, so again, here's where we are. And what would this part of the sky be without mentioning the Crab Nebula? This is the very first of the Messier objects, M1. This is a supernova remnant and also a pulsar wind nebula. And so here's the V, here's Aldebaran, here's the kind of V of Taurus. And then if you kind of follow this line all the way down and slightly over, that's where you'll find it. And what's cool about this one is that this was the first object, the first supernova remnant actually associated with an actual historical event. So back in 1054, Chinese astronomers recorded a supernova, and we now know that was the Crab Nebula, probably also recorded by Japanese, Indian, other astronomers. This is an oval-shaped mass of filaments that are thought to be remnants of that progenitor star's atmosphere and now consisting of ionized gases. And also at the center of this lies a neutron star about 28 to 30 kilometers across that spins at a rate of 30.2 times per second. And emits pulses of radiation across the spectrum from gamma rays to radio waves, therefore making it a pulsar wind nebula. It's generally considered the brightest persistent gamma ray source in our night sky. Also, the material being ejected from this nebula is moving at more than 3 million miles per hour, and it's expanding outward. I guess the first drawing of this object by some Earl back in history, it looked like a crab, and therefore that gave it its name, the Crab Nebula. Its magnitude 8.4 and about 6,500 light years away. I recorded this one. I've never spent too much time on the crab. Actually, it's usually like a blob-like patch for me. Anyone, Suresh or Trina, Steve, anyone else have thoughts about the crab?
It's just a weird looking object when you first come across it. And even though it's near a bright star, it's not always the easiest to find. It's smaller than it seems like it will be. But once you find it, it just looks odd. It looks like a little cloud. And some of these tendrils that you pointed out here on the front of it, you can see some of that detail through the telescope. That's what I remember.
Yep. I did try it through binoculars recently, and it was a no-go for me. So. All right, so we've talked about a lot of deep sky ones that are maybe more challenging, but there's obviously parts of the winter hexagon that you don't need any equipment and you can just appreciate them on any night of the winter. And that would include the Pleiades. This is Messier 45. It's the nearest Messier object to us. It's 444 light years away. It's magnitude 1.6, about 12 light years across. And just briefly, the Pleiades were the daughters of Atlas. And Atlas was a second generation Titan. The Titans were kind of like gods, but they had lesser power than the gods. Atlas was upset about the fact that they had lesser power than the gods and rebelled against the gods and lost the rebellion. So Atlas was condemned to forever support the heavens on his shoulders. His daughters, the Pleiades, were in grief over the destruction of their father. And so Jupiter placed the Pleiades in the sky so that they could be close to their father, Atlas. And typically, it's also known as the Seven Sisters, and typically there's one of the 6 stars that's much harder to spot by people. Sometimes there's mythology around that. It's referred to as the lost Pleiad, and maybe this is because the star Electra was so much in sorrow over the loss of her father that she decided to hide her light from others. There's also kind of a story where Orion fell in love with the Pleiades, and he's always forever chasing them across the sky where Jupiter placed them. But these actually represent about 1,000 stars loosely bound by gravity, but visually dominated by these brightest stars. And as I mentioned with an earlier object that was similar to the Pleiades, this is a cluster of hot blue luminous stars that are relatively young. And there's still, you'll notice around several of the Pleiades, this kind of blue nebulosity, which is the result of starlight scattering and reflecting off the interstellar dust in the vicinity. These stars are, as far as I know, these stars are regarded as sort of plowing through this area of the night sky and sort of lighting up the dust in the area.
It's a pretty young cluster.
Yes, it's a very young cluster. And scientists estimate that it will survive. Like I mentioned earlier, a lot of open clusters will, at some point in the very, very far future, no longer exist. So astronomers think that this one will survive for about another 250 million years. So thankfully, it will still be here during our lifetime. Oh yeah, I wanted to say this dust cloud is estimated to be moving through space at about 18 kilometers per second relative, or sorry, the dust cloud is estimated to be moving at a speed of approximately 18 kilometers per second relative to the stars in the cluster. When I look at this one through a telescope, I like the little, I call them snake bites, the little, you can see all these like bright little pairs of stars that are kind of cute. Any other thoughts or comments about the Pleiades?
It's bigger than it seems in the sky. It's hard to fit that in one field of view in a telescope.
Yeah, definitely. Okay, and then the other bright cluster, naked eye, is the Hyades, Caldwell 41. This is the nearest open cluster to us. It's only 153 light years away, and it's a roughly spherical group of 200 and up to 1,000 stars within a region some 20 light years across. And all of the stars in this cluster have a common origin. They share common chemical characteristics. They're sharing the same motion through space, and they've also been maintained as a cluster for more than 6 million years under the force of their mutual gravity. This shines at about 0.5 magnitude, and this is that V shape. When you look at Taurus, that's obviously V shape in the sky. And then together with the Pleiades and the Hyades, so here's the Hyades, here's the Pleiades. Because the ecliptic, which is the plane of our solar system where the planets are, you can see Mars right there, because that passes through, these are sometimes also referred to as the Golden Gate of the ecliptic. And then I'll just briefly give this story. So the Hyades were, let me go to the Hyades here. The Hyades were nymphs, which are female deities who are possibly also personifications of nature. And this group of women were the half-sisters of the Pleiades. The god Dionysus was given to them as a baby, and Jupiter entrusted them to raise him. They also had a brother who was a great hunter, but was killed by a wild boar. So partially as a result of their grief at the loss of their brother, but also as a reward for raising Dionysus, Jupiter set them among the stars. And they're sometimes also referred to as the rainy ones, since it's said that when their tears fall as rain in November or in early May, when the Hyades is near the Earth, their tears fall as rain at those times of the year. And that concludes our tour. So get out there and check out at least some of those objects this winter. I know often in the winter weather is a deterrent, but if you can get out and do some observing, definitely do so. I wanted to mention briefly before we do Q&A, here's Dave's book that I mentioned, and I did mention that the second edition does contain mythology other than just the Greek and Roman. And also Dave's presentation for the BSIG back in 2021 should be up on YouTube. And then Steve, Steve, you said you're putting together some resources. For this presentation, I used Stellarium. I also always use Sky Safari. I use the Pro version typically. So those are two really great resources if you have not checked those out. any questions, any thoughts, any comments?
So Michael Cowper had a comment when you were describing M1, the Crab Nebula.
Yeah.
He mentioned that the world's first gamma ray telescope was actually developed at the University of Minnesota,
Oh, wow.
and it was launched, I guess, on a balloon from Churchill, which is in Canada. And the first target was the Crab Nebula.
Cool.
Does anybody else have any questions or comments for Claire? I have a question I'll ask. I'm going to see if everybody else has a question first.
All right, go for it.
So when you mentioned M1, the Crab Nebula, Claire,
Yeah.
do you know why it's M1? Do you know why it's the first Messier?
I know it's
object?
the first Messier, but I don't know the story with Charles Messier, other than he was looking for comets.
So Charles Messier was a French astronomer who wanted to become famous. And so back then in the mid 1700s, the way to become famous was to find comets because your name got attached to them. So he was always looking for comets. So he wanted to find, so at this time period, 1758, corresponded to when astronomers suspected Halley's Comet might come back, based on a prediction by Edmund Halley in, I think, 1682 or so. And so every astronomer in the world was out looking for Halley's Comet. And Messier was out looking, and they're supposedly going to be first seen in Taurus. So he's scanning around in Taurus and runs into a blob that he thinks is Halley's Comet, and he gets so excited.
I described it as a blob, right?
He's going to be so famous, right? And it turns out it didn't move. So he was all disappointed, and that became M1, the Crab Nebula. And he decided he was going to then chart all the other ones that he saw that weren't comets.
All the other annoying objects.
All the other annoying objects, and he created his list. And a few days or maybe a week later, a German farmer found Halley's Comet in Taurus. So it was nearby. Messier never saw it. So that's why it's M1, even though it's such a strange object to be M1, right?
Right.
It's kind of small and faint.
Well, I guess we're all grateful that there were so many annoying not comets in the sky that he started to catalog, right?
Yeah, it's a fantastic list. I think you'd probably agree. I'd suggest that anybody that's just beginning in astronomy and wants to look for some deep sky objects and see different kinds of deep sky objects, start with the Messier list.
I would agree.
That's basically some of the best objects we have that we can see from the Northern Hemisphere. Mike, I'm not sure which Mike this is, but Mike asks, are there any other clusters that open and close? I'm not sure what he means by closed. Probably, because I think maybe he's asking, are there any other open clusters or globulars maybe? Mike, if you want to chime in.
Oh, there are many other, even in this part of the sky, I didn't even scratch the surface. I decided to, in terms of globulars, I think there's one other, do you know off the top of your head, Suresh? There's one other weird globular in that part of the, in the winter part of the sky, but another Messier globular. And in terms of globulars, you're not going to find any others as far as I know in that part of the sky, but open clusters, there's many other NGC and other objects that I didn't even scratch the surface. I just focused on, like Suresh said, I tried to focus on the ones that are the brightest, the most well-known, and the most accessible for beginners.
This is Mike. I don't know if you can hear me or not.
Yeah, we can.
Yeah, we can hear
Okay,
you.
all right. I just understood always that clusters were either open and closed, and I was wondering if there were other types of clusters than open and closed.
Probably, do you mean like open clusters and globular clusters?
Yeah.
Yeah, there's no such thing as a closed cluster, Mike.
Okay, I'm just a novice, so.
Sure, go
Oh,
ahead.
no,
Claire.
that's okay. You might be like open clusters are usually more, like I said, more dispersed.
Spread out.
In like wider patterns, and they're younger and they're probably going to go off on their own at some point. Globulars they remind me of like the head of a dandelion. They're really tight, densely packed stars that are usually very old, although they can have young stars in there if they collide or whatever. But
oh, that's exactly right. Open clusters tend to be young, and over time they'll disperse. They're loosely held together gravitationally, whereas globular clusters are like star cities. So open clusters, you might get up to a couple hundred in one cluster. Globular clusters, you can have up to 1 million stars.
And so by closed, you might mean a globular.
Yeah.
Yep. my own personal bias. I think that there's some beautiful open clusters, but I love globulars. It's one of my favorite things. That was my favorite project I've done so far.
Yeah. The other thing too about open clusters is you tend to find them in the spiral arms of galaxies, like in our Milky Way along the spiral arms, because that's where the gas and dust is that forms them. Whereas globular clusters tend to hang around in the halo of the galaxy.
Out.
Yeah, they kind of orbit the galaxy.
I'm still sharing my screen, right? So
yeah, this is, thank you.
Right.
Does anybody else have any questions or comments for Claire? Veronica's asking, what's the name of Dave's book?
That was it's called The Mythology of the Night Sky. I think you can get it on Amazon, is that right?
I don't know.
I think I got it at a club meeting a long time ago. I can't remember.
Les Poltrek mentions stellar associations are also considered a type of cluster. They are like open clusters, but not gravitationally bound.
Associations are like the stars have wandered off and they're no longer gravitationally bound, but they still have a similar origin. Like they all went off.
Similar composition.
Yeah, but they all started in the same kind of place. Yeah, I didn't get into they're in the Orion area. Well, actually in this whole part of the sky, there's various associations.
Michael
the OB1 association and all of that.
Sorry, Michael Copper agrees that you can get Dave's books on Amazon.
Okay. Great.
And Mary Helen Inskeep mentions the Pleiades is useful for those of us who do not have easy access to dark sky locations. It can often be seen with binoculars, even from downtown, despite the parks getting more and more restrictive about their open hours and adding more lights.
Oh, wow.
We need to make downtowns aware that stargazing is still a thing. We all agree with that comment.
Preaching to the choir with that, for sure.
This is great. Any other questions or comments?
I was trying to kind of show, like, can you still see my screen?
Yeah.
Okay, so here's our, edge on of our galaxy. So like the halo, when we're talking about the halo, this is kind of where you typically find the globulars, right?
Oh, in the halo of the Milky Way. Yeah, exactly. Yep. One thing that's interesting about this part of the sky, Claire, in that chart you have right there, is since we're looking out away from our galaxy, you'd expect to see more galaxies in this part of the sky than we really do. There's no really bright galaxies in this part of the sky, which is really surprising. True. If you, I think the spring sky would be over to the, let's see, would it be to the left? It'd be to the right. In the spring sky, if you could circle left, like on your screen a little bit, like with your cursor to the right.
Yeah, here, like.
That I think is that spring? Yeah, that's probably spring to the left. I'm trying to think. The Sagittarius is to the right. But anyway, you get a lot of galaxies in that part of the sky, but you don't get a whole lot of them in the winter part of the sky, which is really odd.
We do have some, like the presentation I did recently at Camelopardalis.
The hidden galaxies.
Yeah, there are some in this part of the sky, right?
Yeah, I know that this winter Milky Way cuts through Orion. That's probably part of it.
Yeah,
Rigel.
right.
But you'd expect to see more than we do. Les Poltrek asks, where can we get that great image in your presentation of the galaxy from above? I think it's this one.
This one?
Yeah, it sounds like it.
I think it might be on a Wikipedia of the Milky Way. I'm not sure. Can't remember. I will, again, Suresh, if we could put together a list of resources, I could include a few URLs, including this image. Yeah,
I've written the books down, and I'll add the galaxy image.
I love looking at, I don't know, I like trying to orient myself all the time. So I like trying to orient myself within the Milky Way here.
Steve G mentions, thanks for putting this presentation together, Claire. I have heard about the winter hex in the past, but I've never found any information in my books or atlases that describe the 6 individual stars as a group or cover any other objects in the vicinity of the hex. This will be a chance for myself to look into this area this winter and in detail.
Nice.
Any other questions or comments for Claire? All right, I guess that's it. I actually finished right on time, Claire, an hour and a half.
Perfect. We planned it that way, right?
It's perfect. Yeah, this is great. You did a really nice job.
Thank you.
So I think I counted 37 people at the peak of attendees. So that's a great crowd for us. Let's see. Chris Holtner says, I knew there was a reason Camelopardalis was in my mind. It was featured on the cover of Guy Atwell's 2023 calendar.
Oh, interesting. Huh. Okay.
You're getting a bunch of thank yous and excellently done comments in the chat here. I will just mention that the next BSIG is scheduled for January 7th, Saturday at 1 o'clock. If Steve Emmert's still on, Steve, do you want to do a quick 10-second on what you're going to discuss? I don't know if he's still on or not. He's going to talk about star maps and other visual aids for beginner observers to use. Steve comes to this with a lot of knowledge and a lot of experience, so I think he's going to touch upon Sky Safari and Stellarium, as well as some of the other like Wiltirian's Atlas, Uranometria, and some of the other visual aids that we visual observers use to navigate the sky. So I welcome everybody to come attend that presentation again, and that'll be on January 7th at 1 o'clock. And if nobody else has a question or comment, I think we're good to go. Thank you, Claire, so much for doing this.
All right. Yeah. Thank you, everyone, for
Awesome
attending.
job, and we look forward to seeing you guys again out under our sky once it's warm enough that we don't die of frostbite.
Have a great holiday. We'll see you in the new year.
Take care, guys. Happy New
All right,
Year to everybody.
thanks, everyone.
Bye.
Bye.